which means the mass given will be converted first to mole, and they gave us 2.7 grams of what? Aluminium. So let's convert to mole using the formula N equal to given mass all over molar mass. N means mole. Gm here means given mass, which is this 2.7. So 2.7 all over molar mass. What's the molar mass of aluminium? As you can see here, is giving us, it is given as 27, and that's what it is, whether given or not. Then we have here 27, and 2.7 divided by 27 is automatically 0.1. Learn this to save more time. Anytime similar number divide each other, only that they differ in the position of the point. For example, 4.8 divided by 48 will automatically give you 0.1. 98 or 9.8, sorry, divided by 98 will automatically give you 0.1. Understood? So let's use a calculator to confirm. We use this 2.7, of course. 2.7 divided by 27 is giving us a 0. Okay, I have to set this. Imagine. Yeah. What do I go to? Oh, it's going to be decimal. You see, it's in 0 decimal places. Let's choose automatic. That will solve the problem for us. Okay, we go again. 2.7 divided by 27 is 0.1. As you can see, this is 0.1. So, which means we go back to our solving board. Therefore, I am correct. Okay, you're welcome to Sa Majesty Easy World Science channel, the Easy World of Science. Today we'll be handling clearly the past questions, actually the questions WAEC 2023 objective questions, the GCE, that's the private exam. So I will be as precise as possible, but I'll hit the point and give you the cheats needed. Then let's lift the questions gradually. Okay, this is the first page, of course. Then we take the first question. The first question says ionization energy is the energy required to A, make gaseous ions react. No. B says add electron to gaseous atom. No. C says remove a valence electron from a gaseous atom. Of course, option C is the correct thing. Then D says promote an electron from one shell to another in a gaseous atom. That's the excitation, and the excitation is not the same thing as ionization. In ionization, electron is lost, removed completely, but in promotion, electron is moved from a lower energy level to higher energy level. So the correct answer to question number 1 is C. Then number 2 says solubility of alcohols in water is due to A, their low boiling points. No. Their low freezing points. No. Their covalent character. No. The presence of hydroxy group. Yes, of course. The presence of OH, which actually gives them polar nature. Why would the hydroxy group make them soluble in water? It makes the alcohols polar in nature, because if you come to alcohols, the formula is ROH, whereby the R is the alkyl group, and the alkyl group generally is actually having a charge of negative. We take it because it is mainly carbon and hydrogen, which are actually non-polar. Maybe C2H5OH for alcohol. You find out that from this point, this particular C2H5 is the R and is negatively what? Charged. But this is negatively charged, of course. But this OH is also negatively charged. But because the OH is extremely negatively charged, this particular alkyl group tends to be plus. Therefore, the OH gives the alcohol polarity, and when they are polar, they will dissolve in water, and water is a polar solvent. Then, polar solvents dissolves polar solutes. Take note of that. Number 3 says if the time taken for a reaction to occur is halved when the temperature of the mixture is doubled, the rate of the reaction would be. What happens to the rate of the reaction? How do we do this? Let's minimize a bit and solve here. You know that rate of reaction is measured by volume produced all over time or mass converted all over time. So let's keep mass or volume constant. Let's assume that at a particular temperature, 20 grams of the reactant is converted in 10 seconds. That means that the rate here is 20 grams per 10 seconds. What the question says, what if they said if the time taken on reaction occur is halved? So let's half this, let's get the half of 10, which is 5, and keep the number constant, which is 20 grams all over 5. You find out that 20 over 10, the answer to this is 2, while 20 over 5 is 4. Therefore, the rate of reaction is doubled because the double of 2 is 4. If you say 2 times 2, that's double means times 2 is 4. So the answer should be when the time taken for a given reaction is halved because of increase in temperature, it means that that increase in temperature has doubled the rate of what? Reaction. So number 3, the answer is A. 4 says electrochemical cells that cannot be recharged are primary cells. Examples of such primary cells are the Loclange cell, the Daniels cell. So these cells are primary cells, they cannot be recharged. That is, when we say the battery you use in your remote, most of the little gadgets you have at home, they are the Loclange what cells. We no longer use this Daniel cell, but Loclange cell is still in use now. Okay, so we take next question, which is question, the opposite of primary cell is secondary cell. Before I leave that question, for secondary cell, examples of secondary cell is the lead acid accumulator, that's the battery, the what do you call it, that's the car battery, of course. So car batteries are actually, for this one, we talk about the car battery or the lead acid accumulator. Okay, then number 5 says, which of the following pairs of gases would change the color of damp red litmus paper? Will change the color of damp red litmus paper. So our main topic sentence here is the red litmus. So this red litmus, what can alter the color of it? First, we should know the acronym, which says BRB and then ABR. This B here is for base, then this R here is for red, and this other B here is for blue. Therefore, with regard to litmus paper, bases turn red litmus paper blue, but acids turn blue litmus paper red. Therefore, for anything that will have effect on the color of anything that will have effect on the red litmus paper must be what? Basic, because that's why we have BRB. Now, carbon 4 oxide is an oxide of non-metal. That's option A says carbon 4 oxide. No, carbon 4 oxide is acidic gas and we turn blue litmus paper red, so it will not affect the color of red litmus. Chlorine, yes, will affect the color of litmus, but not because it's an acid or base, rather it will bleach it because chlorine is a bleaching agent. Now B says ammonia and chlorine. Yes, ammonia is automatically an alkaline gas. So this ammonia is an alkaline gas, that is a basic gas, and we turn red litmus paper blue. But this chlorine is an acidic gas. In the presence of water, chlorine forms an acid known as oxochlorate 1 acid, that is this HOCl. If you dissolve chlorine in water, it gives you this, and this particular thing here is an acid. Okay, this HOCl is an acid, and that is what we call oxochlorate 1 acid. The APAC name should be oxochlorate 1 acid. So it's supposed not to affect the color of red litmus, being an acidic gas, but because it's a bleaching agent, chlorine is a bleaching agent, it will turn red litmus paper white, colorless, not changing it from red to blue. No, rather it will turn blue to red and then finally bleach it or decolorize it. So the correct answer is B. So some of these questions have been answered, although the answer continuous from the person I collected this paper from. So materials that can be deformed. Okay, I was the person that even answered this for the person. Materials that can be deformed permanently by heat and pressure are called deformed permanently by heat and pressure. What matters here is that permanent, and it was highlighted. That's one-time business. So the one that can be done permanently, that cannot be remolded or remelted, is thermoset. Thermosets like silicone, they cannot be remolded. But thermoplastics like nylon, the PMMA, that's the perspex, they are all thermoplastic, and many of the examples you see on the screen. Then we have that we have settled question 6. We now lift other questions as we remove this one. Okay. Let's lift from 7. From 7. Check where, okay. This is probably going to be 7. Yeah, we are there. Now, question 7. Okay. I assigned it to this level. Okay. The metal that reacts very quickly with chlorine. In this case, you use your activity series. Among the metals in the option, silver is option A, which is among the least reactive metals. They are below hydrogen in the activity series. They are lower in the series. That's activity series of metals. Then B says mercury, which is also lower in the series. Gold is also lower. So among all the options, A to C are all classified as the least reactive. The only one that is above hydrogen and very reactive is magnesium. So magnesium should be the answer in this case. So our correct answer is D. Now, if you are faced with this type of question, you use your activity series to answer it. Then number 8 says, which of the following substances is an acid salt? Clean. We have B. How do we know acid salts? Remember, don't say acidic salts. We have 5 types of salts, which are normal salts, acid salt, basic salt, complex salts, and double salts. You stay subscribed so that I'll teach you how to identify and then give you the details on the preparation of each of these classes of salts. But here, I'm going to explain something. If you see any salt that have hydrogen in it, because of this hydrogen, that makes it, that's option B. There is sodium hydrogen tetraoxosulfate, what, 6, is an acid salt. But the one that have OH in it is a basic salt. So option C is a basic what? Salt. But salt that have neither OH or hydroxy group and no complex ion, and there is no 3 ions, only 2 ions, therefore that one is a normal salt. So option A and D are all normal salts. Do you understand that now? Remember, acid salts are formed when there are insufficient base to neutralize the whole acid molecules during acid-base neutralization reaction. But when there are excess base molecules than the acid, it gives us what we call the basic salts. You got that? So most reactions, like for the production of B, if you react HCl with sodium, if you react sodium chloride, first of all, if you react sodium chloride with H2SO4, it will give you the first salt formed will be automatically the acid salt. It will give you the acid salt, which is in the option sodium hydrogen tetraoxosulfate 6, then plus water, because this is neutralization. But on further reaction of this particular acid salt with excess acid, it will give you, with excess sodium chloride, it will give you further a normal salt. You get that now? So in that case, you have that this is an acid salt, but when you continue the reaction, you proceed to, it will give you a normal, there is automatically, where is the, this is not a neutralization reaction, I'm making a mistake. H2SO4 plus sodium chloride will give you Na, then plus HCl. Yes, not H2O, please. There should be HCl, not H2O, plus HCl. Then when you further react this with the acid, it gives you now the normal salt. Understood? Yes. Now let's go back to the question, and then number 9 says if the quantity of electricity required to deposit 2.7 grams of aluminium from each solution is 28950 coulombs, what mass of copper would be deposited by the same quantity of electricity? So this one is Faraday's second law. You watch my video here on the cheats on how to solve Michael Faraday's second law. This one is second law. How do you know it's second law? It mentioned, just watch what I'm highlighting. It mentioned aluminium, and again is now asking us about copper, and they have different charges. Aluminium has charge of, aluminium ion is actually Al3+, while copper is Cu2+. So copper and aluminium have different what? Charges, and that means they are different electrolytes, and the same quantity of electricity is passed through them. You'll be using Michael Faraday's second law of electrolysis. What must you do here first? What you are required to do here in this step for solving is to convert the aluminium, the gram of aluminium given, to mole. So which means the mass given will be converted first to mole, and they gave us 2.7 grams of what? Aluminium. So let's convert to mole using the formula N equal to given mass all over molar mass. N means mole. GM here means given mass, which is this 2.7. So 2.7 all over molar mass. What's the molar mass of aluminium? As you can see here, is giving us, it is given as 27, and that's what it is, whether given or not. Then we have here 27, and 2.7 divided by 27 is automatically 0.1. Learn this to save more time. Anytime similar number divide each other, only that they differ in the position of the point. For example, 4.8 divided by 48 will automatically give you 0.1. 98 or 9.8, sorry, divided by 98 will automatically give you 0.1. Understood? So let's use a calculator to confirm. We use this. Now we said that we were dividing 2.7, of course. 2.7 divided by 27 is giving us a 0. Okay, I have to set this. Imagine. Yeah. What do I go to? Oh, it's going to be decimal. You see, it's in 0 decimal places. Let's choose automatic. That will solve the problem for us. Okay, we go again. 2.7 divided by 27 is 0.1. As you can see, this is 0.1. So, which means we go back to our solving board. Therefore, I am correct. And you learn this, when similar number divide in that form, it is automatically 0.1. Therefore, the number of moles of copper, the number of moles of aluminium provided was 0.1. Remember, the second law says that when the same quantity of electricity is passed through different electrolytes connected in series, that the number of moles, not the mass, the number of moles of the elements discharged is inversely proportional to the charges present on the ion, which means this is Al3+. They are now asking us the one present in Cu2+. First of all, for you to get the one present in this Cu2+, you must get the one present in +1. You must go back. Remember, there was a number, there was a mole that gave us the 0.1, and that number is unknown. For you to know that number, you are going to do inverse of this charge here, which is +3. Inverse of 3 is 1/3. Inverse of 2 is 1/2. Inverse meaning bring what is in the denominator to the numerator, and numerator become the denominator. 2 normally in mathematics means 2/1, so inverse of it means 1/2. 4 means just 4/1, then the inverse of 4 should be 1/4. Therefore, the inverse of 3 is automatically 1/3. So 1/3 times unknown number gave us this 0.1. Therefore, how do we now get our 3? our x will now be automatically, what I did was 1 over 3 times x. This x is the one with the single charge. That's why I'm taking x as the one that have plus 1, gave us 0.1, such that what becomes x over 3 is equal to 0.1, such that now 3 times 0.1 is equal to x. Therefore, the element that has the charge of plus 1, let's assume x plus, how many moles of x plus will be discharged? 0.3, because 3 times 0.1, that is 3 times 0.1 is equal to 0.3. In this case, we have gotten our x. Remember, when you watch down my video, that is what I call x factor. So you must get the x factor. Our x factor here is 0.3. Remember, if they gave us the mass for one charge, like here, in that question, if aluminum has only one charge, you have gotten automatically 0.1 becomes automatically our x factor. But because aluminum is plus 3, we have to go and get the x factor, which is the mole for plus 1. That's the x factor. I mean, watch that video. Okay, that's cheats on how to calculate Faraday's second laws of electrolysis. That's questions concerning that. Now, having gotten our x factor, we now go back to take that of copper, because they are asking us for copper, which is having the charge of plus 2. What is the inverse of 2? The inverse of 2 is 1 over 2 times our x factor, which is 0.3. And this automatically means 0.3 divided by 2. And 0.3 divided by 2 should give us 0.15, of course. Therefore, this is the number of moles of what? Copper discharged. We are now good to go back and now do normal calculation. They said, what mass of copper? Since we have gotten the mole of copper, we now convert that mole to what? Mass. Remember, we are not required to use this number. Why? Because it's just there. They say the same quantity. That is, the word there say the same quantity, which means this 28950 is just like a constant. You got that? Yes. Now we go back to what we're solving. To convert the number of moles of copper to mass, we have that automatically. You use the same formula, which says N equal to reacting mass or giving mass all over molar mass. Our N here is 0.15. 0.15 is equal to reacting mass or giving mass. That's what we don't know. The molar mass of copper is 64. Is given in brackets in that question. It is very much clearly specified in the question, as you can see here. That's 64. So we go back. 0.15 times 64, that's our Rm. Rm is equal to 0.15 times 64. We go to our calculator department, but we can use our head to find out. You can remove that 5, that's 0.05, and just say 0.1 times 64, which is automatically 6.4. Yes, of course. Then 0.5, half of 6.4 is 3.2. So if you sum up this, you get 6, get 9. So the answer should be 9.6. So the reacting mass should be 9.6. But let me use calculator to be sure. Okay. We are calculating 0.15 times 64. That's 9.6 automatically. So the answer is 9.6. We go back to the question and check if we have 9.6. Of course we do. So 9.6 is option B. That's the correct answer. Number 10 says, which of the following statements is not correct? A. An amphoteric oxide exhibits both acidic and basic properties. Yes, it's correct. That's why it is amphoteric. Remember, the word ampho means doer, having two properties. Anytime you hear about this AMH, amphi or ampho, is just talking about if you can use the term 2 in 1, having a double existence. If you come to biology, we have amphibians, which means living in water and also living in land. In chemistry, you have amphoteric oxides, meaning having both acidic and what? Basic properties. So I'm teaching you science language. Anytime you hear ampho or amphi, it means doer, double, having two properties in one. Okay, so option A is correct. B says metals ionize by electron loss and non-metals ionized by electron gain. Very correct. C says in the electrolysis of concentrated sodium chloride, concentrated, our interest is in that concentrated. And remember, concentrated sodium chloride means brine. Concentrated sodium chloride can be termed what? Brine. So that's it. So it is not the same thing as dilute sodium chloride. Dilute sodium chloride is not called brine. They say in the electrolysis of concentrated sodium chloride, hydrogen is evolved at the anode. Anode? No, hydrogen can never be evolved at anode during electrolysis because hydrogen is positively charged, and when it's positively charged, it goes to the cathode, which is negatively charged during electrolysis. So the statement in C is incorrect. So the answer is C. Number 11 says the color of phenolphthalein indicator in dilute triiodonitrified acid is, they want to give us bonus, that is A, is colorless. Phenolphthalein is colorless in all acid but pink in bases. Then in neutral solutions is very, very pale pink, also colorless in neutral solutions. Then number 12 says an element in group 1 of the periodic table would A, form an insoluble chloride. No. All the chlorides of alkali metals, alkali metals are metals in the group 1 of the periodic table. They are all soluble, no exception. Then they form an acidic oxide. No. Group 1 elements are metals, and oxides of metals are basic oxides. They are basic oxides because they react with water to form bases or form alkalis, and in the presence of acid, they form salt and water, of course. Now, the other option says the table would produce hydrogen from cold water. Yes, of course. That's a reaction of sodium with water means starting fire with water. If you react most of the group 1 metals with cold water, they ignite, they catch fire as they release hydrogen gas. It's a dangerous reaction. Don't attempt it. Number D says, option D says, produce effervescent with a base. Not really. Not really. Then number 13 says, what is the concentration of potassium ions produced when 4.35 grams of potassium tetraoxosulfate 6 is dissolved in water and made up to 50.0 cm cube? First, we have to take a look at the compound in question, and that compound in question is K2SO4. We have to dissociate it first. We need to dissociate the compound in question, and that is K2SO4. On dissociation into cations and anion will give us the cation K plus, and then the anion is SO4 2 minus. Balance the atoms and the charges. We have 2 atoms of potassium here, but we have 1 here, therefore we should put 2 here, and that makes it balanced. There should be 2 here, then plus should be here. This means they are talking about ions produced from K2SO4. This means that 1 mole of K2SO4 on ionization will automatically give us 2 moles of potassium ion. Then we go back and see the question they are asking us. They now say, what is the concentration of potassium ions? Okay, 4.35 gram of potassium tetrasulfate 6 was dissolved in 50 cm cube, but the answers we are seeing is in mole per dm cube, not in 50 cm cube. Therefore, we are going to find out the amount in 1000, not the amount in 50, and this implies that we have to go back here in our solving board, and then the solving paper, we have that they gave us 4.35 grams dissolved in 50 cm cube. You now ask yourself how many will be in 1000 will contain what? Then you cross multiply. 50x is equal to 4.35 times 1000, such that x alone is 4.35 times 1000 divided by 50. Now, by mere reasoning of this, we can reason this even without calculator. Let's cancel 0, 0 cancel 0. then 5 can still go, yes, of course. 1, if 5 go by 100 is 20. Therefore, if we have that 4.35 times 20, the cheat on how to do this with our calculator, how many zeros do we have after this 2? That's under here. We are multiplying this, right? Then how many zeros after this 2? Only 1 0. That means I'll go and shift this point here. So if I move that point forward, I've cancelled that 0. Let's assume there are 2 zeros here. I'll move this point to 1, 2. Therefore, let's apply this. It's a way to help you, assuming you're writing jam where calculator might not be there. You can help yourself and reason it out. So since I want to cancel off this 0, I will now shift that point to become 3.5 times 2. I have automatically eliminated 0 by shifting point. So this is what I call eliminating 0 by shifting the position of your point. Yes. Now, in this case, these 2 remain. So 43 times 2 is automatically 86. Then 0.5 times 2 is 1. Therefore, this is going to be 87. Now, what they gave us is 87 grams per mole. So it means that the concentration of the K2SO4 is actually 87 grams. Therefore, from the equation here, we discover that 1 mole of this will give us this. Then convert this mole to mass. The molar mass of K2SO4, I think they gave us that. Yes, they say it is 174.2. So we now come back here and use that fact, in the sense that if 174.2 will give us 2 what? Moles of potassium. Remember, from the equation I balanced, I dissociated 87 grams, which was the amount in the solution, will give us X. May looking at this, 87 is automatically gotten by dividing 174 into 2. So if you say 174 divided by 2, this is what I call division factor. Also watch my cheats. Endeavor to watch calculation cheats in chemistry, or shortcuts in chemistry, or calculation cheats. See how I do some things that you find difficult easier on this channel, Your Majesty Easy World. Now, normally I'm trying to tell you that X is 1 already, but if you are confused, let's do the normal cross multiply. What do we have? We have that 174.2x is equal to 187 times 2. Then 174.2x is equal to 87 times 2 is 174. So that 0.2 is not enough to change our answer. X is equal to 174 divided by 174.2. This will give you something like 0.99999, which is automatically 1. Understood? Yes. So the answer to the question is 1.0 mole concentrations of potassium. Going back to the question, we have such option. Yes, that's option D, number 13. Number 14 says, when iodine crystal is heated, it changes directly to gas. Which of the following statements correctly explains the process? A. Iodine atom are held by strong forces. B. Iodine is a solid at room temperature. C. Iodine is a gas at room temperature. D. Iodine molecules are held by weak forces. Iodine molecules are held by strong forces. No. B. No. Yes, of course, it's a solid at room temperature, but that's not why it sublimes, because what they said there, the question number 14 has just defined and illustrated sublimation. Sublimation do not occur just because something is solid. If not, every other thing will be sublime in every solid, including humans, because we are solids at room temperature. Okay, C. Iodine is a gas at room temperature. Iodine is never a gas at room temperature. That option C is a wrong statement. And being a wrong statement is automatically a wrong answer. Remember that some statements might be correct, but not the answer to the question. Just like B is correct, but not the correct answer to the question. D says iodine molecules are held by weak forces. Yes, of course. Iodine molecules are held by weak forces, probably the van der Waals forces, as is a very, very weak force, just like ammonium chloride the dominant force there. That's why they sublime on heating. Then number 15 says, what happens when crystals of sodium chloride melt? A. Covalent bonds. If you hear sodium chloride, for example, this is sodium chloride, automatically remove in your mind anything covalent, because sodium chloride is an ionic compound or electrovalent, and these two doesn't go together. So electrons, when sodium chloride melts, electrons are released from the atoms. No, melting is not synonymous with ionization. Don't confuse melting with what? Ionization. Don't confuse melting with ionization. So option B is incorrect. Option C says electrostatic forces in the lattice are overcome. D says molecules in the lattice are separated into ions. Melting is not ionization. So B and D are not correct. So C should be the most appropriate answer. In this case, we are done with the one in this page. We lift another one. We lift other ones in those other pages. First, we need to delete this one. This is what I wanted to do. Okay. We clean the notebook before bringing more writing notes. Before we bring the other questions, I think we bring the one that continue from 16 because we stopped at 15 here. Yes, of course. Okay. I think we are good to lift those questions. Checking. I think this is the next. Exactly. We are there. We got it. So question 16 says, as the temperature of water in a sealed container is cooled from 20 degrees to 10 degrees, vapor pressure is just the pressure exerted by the gaseous part of the water. Now that's the vapor. Let's illustrate this. Maybe if this is actually the sealed container, and you have heated the liquid, maybe the liquid now has a vapor. This is the level that is still the liquid. Take here the liquid level. Then above this liquid, you have also the vapor, which is in form of gas, moving, hitting the walls of the container, and that container is sealed. Energetic molecules exerting pressure. But when we say cooling it from 20 to 10 means that some of the gas molecules will lose their kinetic energy and eventually turn to liquid, which means lessening the number of the colliding gas molecules here. The number here will lessen and go into liquid. Therefore, automatically, the answer should be A. As the temperature is decreased, the vapor pressure is also decreased. Yes, that's why the vapor pressure of ice is very low to compare to the vapor pressure of a boiling water. Decrease in temperature means decrease in what? Vapor pressure. Number 17 says, so the answer to this is A. That's number 16. Number 17 says, gases can be compressed because why must we compress gas? Why must we compress gas? A says molecules are light, not a reason. B says molecules are close together. If they are close together already, you don't need to compress now. C, molecules are far apart. D says collision between the gas molecules are elastic. This is C. Yes, the gas molecules are very much far apart, in this case, scattered all over. That's why we say they have the highest degree of entropy. Something like this, you can eventually press them to come together to get something like this, and that's what we call compression. You have pushed them such that the spaces between them they will close the gap. It's just like there is no more space between you and your neighbor. You people can't come closer again. As you can see here, you can't compress this again because there is no more space. Unlike when you have something like this scattered all over, you can push them to come together. Do you understand? So the answer should be C. Number 18 says the unit gram per dm cube is used to express, this is funny, they just want to dash you this mark. Gram per dm cube is used to express mass concentration. This gram is for mass, but if you see mole, you talk about molar concentration, that's molarity, molar concentration. So we will discuss the two concentrations, or three. We have the molarity, we have the mass concentration, you also have the molarity. Don't confuse molarity with molality. Don't confuse molarity with molality. But the one our interest is on is molarity. Molarity is concentration in mole per dm cube. But mass concentration is equal to gram per dm cube. Then what is molality? Is just concentration per 1 gram of the solvent. They are not measuring non-solvent in volume this time around, because dm cube is for volume, but molality is talking about the gram present in 1 kg of solvent. That's the mass, the amount present in 1 kg, or you say the number of moles that will able to be dissolved in 1,000 grams of the solvent. No more dm cube, 1,000 grams of the solvent. So that's molality. Now that is it. I say the option B is the correct answer, mass concentration. Number 19 says which of the following compounds has a giant network structure? Giant covalent compounds are molecules and some other some of them, if I can recall. The giant molecules, graphite, diamond, of course, are seen as the one having giant molecules, and we cannot see any of them here. Therefore, what do? Yeah, silicon 4 oxide is also a giant molecule. Yeah. So according to the options, whereby we might have such a thing like this, I think we need blue here. Okay, this is just an illustration of the so-called giant molecules we encounter. So we see that in silicon 4 oxide, graphite, and also diamond have giant molecules. Naphthalene, benzoic acid, and iodine are not giants. They don't have giant network structure. Number 20 says nitrogen 2 oxide combines readily with oxygen at room temperature to yield nitrogen 2 is NO, combining with oxygen at room temperature to give us NO2. That's what it should be, where 2 should be here and 2 should be here. Normally, I got this experience, which means it's going to be this. During the preparation of this gas, NO2, you need to also, how do you prepare nitrogen 2 oxide in the laboratory? That's NO, sorry, not NO2. NO is nitrogen 2 oxide. So, not NO2 means nitrogen 4 oxide. When you want to prepare nitrogen monoxide, that's NO, you need to react copper metal with HNO3. But what matters now is the temperature, the concentration of this HNO3 will determine which gas will come out. So what I mean here is that reacting copper metal with HNO3 will give you these two possible gases. It will either give you NO or NO2. When this is concentrated will give you NO2. But when this is dilute, will give you NO. Therefore, in the laboratory, when I react HNO3, dilute HNO3 with copper metal, it gives me the colorless gas NO. But if you allow it in the reaction vessel, it starts turning brownish again. That means it's reacting with the oxygen, giving you reddish brown gas, and that's what they just asked us in question 20. So B is the correct answer to that of question 20. Then 21 says, which of the following electron configuration is most stable? We are looking for noble gas. Because noble gases have stable configuration, of which we call octet or duplet. Unfortunately, is there any noble gas that belongs to the D block? Because the whole configuration ended in D. and there is no noble gas that the configuration ends in D. So what do we do? What do we do here? Okay, yeah, we consider based on the D there. In D, there is a special stability with D5 and D10. D5 and D10, and the only thing we saw here is D10, so it should be that of D. That is zinc, probably, because how do you know? Argon is 18 plus these two 20, which is calcium, then 20 plus 10 is 30, and zinc is number 30. So this configuration here, that of zinc, should be the most stable. Option A could have been the part of the stable, but they wrote a wrong configuration. This A supposed to be, I wouldn't say wrong, but this configuration, the little I know chemistry, does not exist, because this is chromium. How to write chromium should be AR 4S1 3D5 and not this. But the answer to this question should be D, because there are special stabilities with the copper and the chromium group in the periodic table, and this might be the reason why they disobey the half-bow principle. That's the pattern of writing configuration. Okay, now number 22 says, how many moles of sodium hydroxide are in 25 cm cube of 0.4 mole per dm cube of each solution? How many moles of sodium hydroxide is this is a very simple thing to do. They said this was given to us in mole per dm cube, so one can just say 1000 divided by 25, and then whatever you get is what you divide 0.4 by the same thing. You just divide 0.4 by the same answer you get here. So maybe calculator department, what do we have? 1000 divided by 25 is 40. So if you divide 0.4 by 40, we'll get the answer. So 0.4 by 40 is supposed to give us 0.01. 0.4 divided by 40, 0.01, correct. Do we have such in the option? 0.01, yeah, option A. Okay, let me solve the usual way that you're supposed to, that you know, the normal way, so that I don't get it twisted. Okay, the correct way of solving is this. Simple. This mole per dm cube means dm cube means 1000 cm cube, and this 0.4 means that it is inside this volume dm cube. Therefore 1000 contains 0.4. 25 will contain x. You do what? You cross multiply, of course. In cross multiplication, what do we have? You have that 1000x is equal to 0.4 times 25, such that x alone is equal to 0.4 times 25 divided by 1000. Our calculator department, it will automatically give us the same 0.01. We say 1000 watts. 0.04 times 25, okay, 0.4, not 0.04, times 25 divided by 1000, 0.01. So 0.01 is our answer. Number 23 says, during a chemical reaction, the mass of the catalyst remains unchanged. The mass of the catalyst, yes, we say that catalysts alter the rate of reaction, but they remain both qualitatively and quantitatively unchanged. So A is a very correct statement. B says physical state of the catalyst remains unchanged. No, the physical state might change. Take note, if it is in lump, it can be in powder. So the physical state can be changed. Then physical composition of the catalyst may change. Physical composition, which is what I just said now. The B and C should be saying the same thing now. D says chemical composition of the catalyst may not change. It will not change. The chemical composition will not change. So, and they said during a chemical reaction, the mass of the catalyst remains unchanged. This one that they put May here, they shouldn't use May. The thing that should be correct is that the chemical composition of the catalyst will not change, not may not change. So because of that, May, A is the correct answer. 24 says, going across the periodic table from left to right, the first ionization energy generally does what? Remember, Her Majesty has come down to compile, to design a wonderful table you are seeing there on the screen. And this table contains numerous information. It has the electronic configuration, the distribution in the shell, the ionization energies, you have the densities. Each box have 9 informations at least, even the ones that are radioactive, to mention but a few. So this table is recommended for schools, institutions, and even for homes, and is available in flex form of different sizes. If you want the name of your institution to be included, it will be included in the space opposite to that place written majestic periodic table, of course. So you are advised to place order for this table. It's very cheap and affordable. I made this table myself because no table is more informative than it. I couldn't find the one I want. What I have to do is I have to go down. It took me up to 3 months to get this design perfect for the information well checked. So as you can see from that table, if you check well the numbers, they are now asking us what happens to ionization energy generally. So let's go back to the question. This one says, normally, going across the periodic table from left to right, the ionization energy generally, automatically, it increases. Of course, it does what? Increases. That is why it's difficult. If you move from left to right in the periodic table, left to right, it means moving from metals to non-metals. If you ever move from left to right in the periodic table, you are moving from metals to non-metals. So it means in ionization energy, metals have very low ionization energy. That's why they easily lose electron. But non-metals have very high ionization energy. That is why it's very difficult to remove electron from them. Rather, they can gain because of their high electron affinity on the opposite. Therefore, when you move from metal to non-metal, ionization energy automatically does what? Increases. Remember, as it is increasing across the period from left to right, it is also decreasing down the group from up to down. Do you understand that now? So the answer should be B. Now we are done with this particular. We are going to lift another page which started from 25, of course. So let's remove this and then get our board, get the paper clean. Okay, you are good to go.
Hi, I wanted to tell you that you can contact Her Majesty for your laboratory equipment and reagents. They are affordable and provide accurate results too. Her Majesty's word only sells what he knows, and his patterns of delivery are sure and certain. Place your orders today. Thanks for your patronage.
Using my prepared filler, you can also place order for any of these apparatus and reagent to Her Majesty. Tackle this. Let me believe this is what we want now. 25 is very correct. That's where we stopped. Okay, question 25 says, remember this is Her Majesty's World Science channel. You can as well as extend your learning time by engaging me in private class. We are busy having our online classes, coaching and training people for exams, especially courses that concerns chemistry and biology. I'll do you well. 25 says an aqueous solution of salt X reacts with aqueous barium chloride to give white precipitate which is soluble in aqueous HNO3. X is likely to contain. This is a fact that we should master. Barium chloride is used to test for 3 anions, and these are SO42 minus, SO3 2 minus, or CO3 2 minus. That's tetraoxosulfate 6 ion, trioxosulfate 4 ion, or trioxocarbonate 4 ion. All these three is detected using barium chloride. So in that case, it implies that, hence they say barium chloride and there is white precipitate, you're supposed to suspect tetraoxosulfate 6 ion, that trioxosulfate 4 ion, or trioxocarbonate 4 ion. But using this acid will now tell us which one is present. These two here, that's trioxosulfate 6 and trioxocarbonate 4 ions, are all soluble in acid. They are all soluble in dilute what? Acids. But tetraoxosulfate 6 ion is what? Insoluble in acids. It doesn't dissolve in what? Acid. Only these two are what? Soluble in acids. Then checking the options, you see that they did not bring the two. It is only one that appeared. The answer is A. The answer is what? A. But let's assume they said insoluble here. The answer will be B. But because they said it dissolved, it is either trioxocarbonate 4 ion or trioxosulfate 6 sulfate 4 ion. So that's just by the way. I guess you are learning chemistry well. 26 says, what mass of copper would be liberated by the same quantity of electricity which liberates 11.20 dm cube of hydrogen measured at STP? This is still relating to second law. They run away from first law this time around. They don't usually ask second law, but this time around, I think they started asking it. So what we're going to do here is check the first element mentioned. They are asking us to find the same copper again. Then they gave us hydrogen gas. Hydrogen gas is a hydrogen ion. Let's write the half cell equation, H plus E to give us H. But hydrogen is diatomic, therefore I will put 2 here. So they are supposed to be 2. In that case, if we have 2 there, it means that this electron have to be 2 and this have to be 2. And therefore, it shows that 2 Faraday, that's 2E means 2F also, will give us 1 mole of hydrogen gas. And 1 mole of any gas at STP is 22.4. Understood? Now, they said, what mass will be, then which one liberated 11.2? If you watch this, you now ask yourself, 11.2 will be liberated by what quantity? X. Automatically, if you check here, the half of 22.4 is 11.2. So what must we do here? Since the half of 22.4 is 11.2, it means we are going to get the half of 2F. Half of 2F, meaning 2F divided by 1 by 2 is 1. So automatically X will give us 1 Faraday. It means that the quantity of electricity supplied is 1 Faraday, which is 96,500 coulombs. The 96,000 is not needed here. We just know that 1 Faraday here. Then we come to the element copper. What do? Remember that copper has a charge of +2. And that means it will require 2 Faraday because of the 2 charges in it. Understood? Therefore, the quantity that was supplied was 1 Faraday. Simple. What do? 2F is needed to give us copper, which is 64. They're supposed to give it to us in bracket there. Yes, copper is 64. So what do we have? See what I did. Cu2 plus 2E will give you Cu. Therefore, this 2E means 2 Faraday. And that will give us 1 mole of copper. And changing this copper to mass, 1 mole of copper is 64. It is given. Therefore, the quantity that was supplied was 1F and not 2F. So if 2F gave us 64, it was 1 Faraday that will liberate 11.2. They are asking us the quantity, the same quantity that gave us 11.2 of hydrogen at STP, what mass of copper will it give? And that quantity was 1F. So 1F gave us 64. 2F gave us 64. 1F will give us X. 1F will give us automatically 32. So the answer is this. To solve, we call here X. That's 2X is equal to 64, such that X is equal to 64 divided by 2, which is 32. So we are done with that. Okay, now next question is question 27. A substance that donates an electron in a chemical reaction is electron donors. The species that donates electron, you now say oxidation and reduction, oil rig of electrons. I often use this. Oxidation and reduction means oil rig of electrons. This implies that O is oxidation, I means involve, then L means loss of electrons. So oxidation involves the loss of electron, but they are asking us for the one that donates the electron. Okay, then reduction involves the gain of electron. But remember here, the agent of darkness is not actually the darkness itself. In that aspect, just know that a substance that donates, the process of donating an electron, you that is donating the electron, you are undergoing oxidation. But you that is donating the electron, that is making yourself oxidized, is a reducing agent. Just take electron as money. If somebody dash you money, he has given you electron. The person giving you money is showing the world that you are poor or poorer. That means reducing you, because normally you even bow for the person and say thank you. Bowing for the person that gave you money, you are reduced. Who made you bow? The person that gave you money. Who is now acting to be rich man? The person that gave you money. So the species that donates electron undergoes oxidation, but that same species that undergo oxidation is a reducing agent. So electron donors are nothing but what? Reducing agent. But electron acceptors are oxidizing agent. The poor man that accepted the money of the rich man is the person that made the rich man feel to be rich. If the rich man bring the money to give to the poor will reject the rich man and the money. The rich man will feel ashamed and nobody will recognize his wealth again. Okay? Then 28 says, which of the following scientists discovered the protons? Protons were discovered by Ernest Rutherford. Some of your textbooks say it's J.J. Thomson, but that's wrong. Ernest Rutherford discovered the protons from the Giga-Marsden alpha scattering experiment. He was able to know that there is existence of a proton. Okay, and he proposed that the miniature solar system as a model to represent an atom. 29 says an element Q contains two isotopes, 107 and 47. That's 47 is the molar, 47 is the mass number. That's why they are the same. While 107 and 108 are actually their mass numbers, which means these two are what? Isotopes. What connects these and this is that they are what? Isotopes, since they have the same atomic number but different mass numbers. Now, how are we going to determine the relative atomic mass? Simple. Take the mass of this one, which is 107, divide it by okay, how do you do it here? 107 divided by 100. Okay, and an element contains two isotopes, 107 and this is in equal proportion. Yeah. Equal proportion is what I'm missing. This equal proportion is very necessary. Equal proportion here stands for 50% is to 50%. So their percentage abundances are actually 50-50. Therefore, how to solve this will automatically be 50% times, that's for this one, times 107 plus the same 50% of 109, 50% of 109. If you sum up this is automatically half. This is 0.5, this is 0.5, so we'll be battling with simple 0.5 times 107, which is half of 107. Can predict the answer self with our calculator, plus the same thing, 0.5 times 109. Okay, So to make it faster for us, we just go to the calculator section. We have 0.5 times 107, which is 0. Oh, I didn't clear what is there. 0.5 times 107 is equal to 53.5. Bear it in mind, 53.5. Therefore, we have here 53.5, then 0.5 times 109, then plus 53.5, which will give you 108. So 108 is option C. That's the answer. Then number 30 says pig iron is brittle because it contains brittle, meaning it cannot be forged, it cannot be remolded, it has a low tensile strength. So that's pig iron, and pig iron is the iron that comes out directly from the blast furnace. Probably the brittle nature is because it has high percentage of carbon as impurities, which when remelted and then treated well will give you cast iron. On further treatment gives you wrought iron. Wrought iron is the purest form of iron and is the one that can be welded and forged, and it has high tensile strength used for production of chains. Then number 31 says the density of pure water is 1 gram per cm cube at what temperature? This should be probably more physics than chemistry, but let me try. Okay. Yes, I've come across something like this. The density of pure water at 1 gram, the density of pure water is 1 gram per cm cube at what temperature? At 0 degrees, the density is 0.998, not exactly, yes. So it is exactly at 4 degrees Celsius, if I can recall. Just pray I'm correct here. So this should be the answer. The little brain reading that it is at this temperature that we have this then, but because if you see this and this on the approximate, they are the same thing now. 0.998 and 0 and 1 is the same thing. Okay, but the differences is what they are looking for here. Number 32 says, what is the mass of silver deposited when a current of 6 amperes is passed through silver triazonitrate 5 solution for 1 minute using graphite electrodes? Okay, you can watch my video here on how to do this calculation, but here I'm going to use the normal thing. But I bet you if you watch that video on the first Faraday's law, because this test is first Faraday, we have solved about 2 questions on electrolysis. The other 2 are actually second law, but this one is the first law. Therefore, what is the element they mentioned? Remember, how do you know first law? They only mention silver here. They are not relating silver with any other thing. But the other one we saw aluminum and copper. The other one we saw hydrogen and copper, you see? But it's only silver that is mentioned here. Do you get that now? That's another way to know which law am I going to use. So the first law says that the quantity discharged is actually the mass discharged, not the quantity either. The mass of the element discharged is directly proportional to the quantity supplied, while quantity is current times time. I here is current, T is time in seconds. Therefore, it implies that we need to know the half cell equation of silver, which is silver is +1. Because it is +1, it will gain 1 electron to become Ag, and since it's gaining 1 electron, it automatically means that it requires 1 Faraday. 1 mole of electron is 1 Faraday, because 1 Faraday is the amount of electricity required to discharge or deposit 1 mole of electron, and is numerically equal to 96,500 coulombs of electricity. Now, converting this Ag to molar mass is 108. We put it here, 108 grams. Now, we go to the quantity supplied. It means that 1 Faraday is the quantity supplied. What is the quantity? I remember this 1 Faraday means 96,500 coulombs. We discharge 108 grams of silver. Then Q is equal to IT. From the question, what is the current given is 6.0 amperes, while the time given is 1 minute. They said pass through silver triazonitrate for 1 minute. So how many seconds are in 1 minute? Our current here is 6.0 amperes, while time in seconds is 1 minute, and 1 minute is equal to 60 seconds. Therefore, quantity supplied is equal to 6 times 60, and 6 times 60 should give you 360. Yeah, it's going to be, the quantity provided is going to be 360 coulombs of electricity. Then because it's just 6 times 0, 6 times 6 is 36 now, so I'm correct. We now go back to this fact here and bring it by saying that 96,500 was able to deposit 108 for us. 360 will deposit what? X. 360 will automatically deposit 108 over 96500 times 360 over 1. Going to the calculator section, we have 108 divided by 965. Okay. Or I might divide the screen either to make it what is that good note? Okay, so that I can see what I'm doing. Over here I'm dividing simple 108 multiplied by what? 360 is equal to, then divide it by 96,500, which will give you 0.4. Do you have anything like that? Yes, that is option A. 0.4 grams is the answer to question 32. So we lift the other. Let's make this our full screen. We're going to lift the other question, so doing, and then get our board cleaned. The notes either that I'm using as board. Okay, we lift from 33, supposedly from 33. I think we touched this. This should be the next. No, this has been answered. That's the same page. Okay, this is 43. Make sure a page is not missing. Okay, yeah, I think I got the right page here. Now 33 says, which of the following pairs of substances are electrolytes? Electrolytes must be either in solution form, that's it is going to be in liquid form, either in aqueous solution form or in molten form, and to be capable of ionizing. So looking at this, option A says there is liquid cannot be electrolyte, liquid without ion. Then aqueous is electrolyte. So A could have been correct, but that ammonia as a liquid is not correct. Then ammonia as a gas is not electrolyte. HCl as liquid is not going to be an electrolyte. It's just a liquefied gas. Then option C says ammonia, aqueous ammonia, yes, is actually an electrolyte. But HCl as a gas is not an electrolyte. So the answer is D. As you can see that the option D are all in aqueous form. That's aqueous ammonia and aqueous HCl. Number 34 says the compound that has octane number of 100 is. Octane number is the number used to ascertain the quality of petrol. There is what we call knocking and anti-knocking agent. Some of the noises we hear from our car engines as they move and combust this fuel is what we call knocking, and then it is a sign of using poor quality petrol. And what do we use to know the quality of petrol? An octane number. So octane number measures the ratio of N-heptane to the ratio of 2,2,4-trimethylpentane. Yeah, the ratio of N-heptane, that's stretch N-heptane to what? 2,2,4 trimethylpentane. The one that have octane number of 100 has this in higher percentage of 100 and 0 of N-heptane. And the question says the compound that has octane number of 100, which is this 2,2,4-trimethylpentane, while this N-heptane has octane number of 0. So, and we don't see this in the option, okay? How many carbons are here? This is 1, 2, then pet is 5, so the answer is B. Yes, another name for 2,2,4-trimethylpentane is isooctane. Yes, I can remember. You see how I just did it? How many carbons are here? 1, 2, 3. That's this 1, 2, and 3. Then pent is 5. So 3 plus 5 is 8, and 8 is oct. So in isooctane, that's another name for 2,2,4-trimethylpentane. They are actually isomers. That is an isomer of octane. That's the meaning of isooctane for here. Now, determine. Question 35 says, I got to clean off this. Question 35 says, determine the empirical formula of a hydrocarbon containing 0.8 moles and 0.2 moles of carbon. That's carbon and hydrogen. So we have carbon, we have hydrogen. Number of moles of carbon is 0.08. Number of hydrogen is 0.32. Here, you don't need to divide by molar mass and just divide by the smallest ratio. The smallest ratio, that's the smaller one among 0.8 and 0.32, and which is 0.08, sorry. 0.08 and 0.32. Which one is smaller? 0.08. So what I'm going to do here is divide both sides by the smaller one. Divide here by the smaller one. So this is automatically 1. And me looking at this, 32, 8 times 2 plus 2. Okay, this is automatically going to be 4. So the empirical formula is CH4. Primary alkanols can be dehydrated to produce alkenes. Lest I forget, over this 34, there is another number you should know, cetane number. Cetane number is also used to assess the quality of diesel. But the quality of petrol is octane number. So, but cetane number is for diesel. Okay, that's why you are on with Her Majesty. Thank you. Please subscribe. Please, I beg of you, subscribe to my channel, share my videos if you are really enjoying this. I cannot do without you. Don't just say okay. Share. Get to your neighbor, let them know that there is a place where things that are difficult can be simplified. So please, if you are not a candle producing the light, you be the mirror that is reflecting it. I'm begging of you, help us produce the light and also help us to reflect. Be a mirror. Now, primary alkanols, that's 36, can be dehydrated to produce. Dehydration of alkanols automatically yields alkenes because it removes the water molecules. Dehydration means the removal of water molecules. So the answer to this is A. And you have primary, secondary, tertiary alkanols. The dehydration of these, all these ones, yields automatically alkenes, and you are advised to use the dehydrating agents to be used here is H2SO4. But when you grow higher, you find out that dehydrating secondary alkanols and tertiary alkanols require dilute H2SO4. But when you are dehydrating primary alkanols, you need to use concentrated H2SO4, because when you use concentrated H2SO4 under tertiary alkanol, the ethene or the alkene, formed will tend to hydrolyze. But this is a higher chemistry for you. Now, number 37 says the empirical formula of the compound of this compound. See how to do this. If you meet this in exam, just count how many carbons. 1, 2, 3, 4. Write it C4. How many hydrogens? 3 plus 2, which is 5, plus 2, 7, plus 1, which is 8. So we have H8. How many oxygen atoms? 1 and 2. O2. So divide by the LCM. What number can divide all this without a remainder? It is 2 automatically. So 4 divided by 2, 8 divided by 2, 2 divided by 2. We have C2, because 4 divided by 2 is 2. H4, 8 divided by 2 is 4. And then O1. This is the empirical formula, which is option B. Okay. Question 38 says biogas consists mostly of methane. Biogas consists mostly of methane. Because of time, I run. 39. The solubility of sodium chloride at 25 degrees is 36.2 gram in 100 gram. 36 in 36.2 in 100 gram of water. What mass of sodium chloride will dissolve in 50 gram, which is half of 100? Automatically, half of 36.2, half of 36 is 18, half of 0.2 is 0.1. So answer to 39 is A. Number 40 says, which of the following arrangements represents the electron configuration of an element with atomic number 11? 1s3 is incorrect. S cannot hold more than 2. 2s3 is incorrect because S cannot also hold more than 2. Then 2p4 4s1 is inconsistent with this law, this Horn's rule. You cannot start filling 3s when 2p is not yet filled. Though if you sum them all, they are 11. Is incorrect. So let me go fast. I don't have much time. Let me look at the options and take the correct answer. The correct answer, sodium, is B. 1s2, 2s2, 2p6, 3s1. Number 41 says the atmospheric pollutant that is a greenhouse gas. Atmospheric pollutant that is a greenhouse gas, carbon dioxide. It has the ability to absorb heat, so it leads to increase in temperature of the earth. So then 42 says the type of bond that exists between nitrogen and hydrogen. Imagine nitrogen and hydrogen. They are two non-metals. The bond existing between nitrogen and hydrogen in ammonia is nothing but covalent. It is formed by the sharing of contributed pairs of electron. We are done with this. We leave probably our last page for this. I'm going to clean off if I leave again. Okay. Even the practicals for this are here, but it's going to be on a separate video. The alternative to practical, then the theories. Okay, in the last section here, 43 says a chemical reaction in which there is a breakdown of molecule breakdown using water is known as breakdown is lysis. Anything lysis means breakdown. Or say I don't have time, so let's move. What do you have? Only one option have lysis, and hydro is water. So the answer is B. Then hydroxonium ion H3O plus is formed from H2O, and that means this lysis is beta LMM. If you see hemolysis, it's just the breakdown of red blood cell. Pyrolysis, everything lysis in science is breaking down, destruction. Electrolysis, decomposition by passing electric current. You see it? So this is another way you can succeed by hearing science language. Hydroxonium ion is formed from water and hydrogen ion by dative bonding. That is what we call coordinate covalent bonding, just like ammonia and hydrogen ion in ammonium ion. 45 says the major constituent of natural gas is methane. They love methane today. Usually through the separating funnel, immiscible liquids A can be separated completely, B can be easily decanted, C cannot be separated, D can be centrifuged. Can easily be decanted. Decantation should be A. So now 47 says which of the following compounds can be identified using ammoniacal silver trioxide nitrate 5 solution. Ammoniacal silver, ammoniacal silver trioxide nitrate 5, meaning silver trioxide nitrate 5 dissolved in aqueous ammonia. We are looking for alkynes. Simple. This test is very much sensitive to what? Alkynes. That is those hydrocarbons that have triple carbon to carbon bond. So option A is off because it has double bond. B is in, D is in. So we are battling with which among D and B will be the answer, because both has what? Triple bond. Now this test is sensitive to terminal alkynes. Yes, and terminal alkynes are the alkynes that have the triple bonds towards the end of the chain, meaning all the one ine, say one ines. Maybe if I say hexan or hex 1 ine, meaning that is towards the end, it dropped one carbon in one side. This is 1 ine, which is option B because it dropped only one carbon here. Therefore, the answer is B. It is not D because D is not a terminal alkyne either. 48 says how many bond pairs of electrons are present in the following molecules? We have 1, 2, that's 1, 2, 3, then 4. But this, by looking at this is 1, 2, 3, 4. It's going to be 4, which is option C. Okay, no. Look up. This is also a bond pair, which means we have to enlarge this. Yes, this is very necessary to understand the word. CH3, then C, triple bond, and the N. So this is talking about bond pair. Each line is a pair. So we're going to count now. This is 1, 2, 3, 4, 5, 6, and 7. Imagine. So the answer, let me count again. 1, 2, 3, 4, 5, 6, and 7. The answer is A. So the number of bond pairs present here is A. Unfortunately, there is no lone pair here. Okay. Then 49 says a mixture of potassium chloride and ammonium chloride can be separated. Potassium chloride do not sublime. It doesn't sublime on heating. So this one do not sublime, but ammonium chloride sublimes on heating. Therefore, if you have mixtures that have one constant subliming, the other is not subliming, you take sublimation. An element that can exist in 2 or more forms in the same physical state is said to exhibit allotropy. So that concludes it for this WAEC 2023 chemistry objective questions, but GCE, not the main WAEC. This is GCE, that's private students. Thank you for watching. God bless you and remain majestic. I cannot do without you. Please, in the God's name, I beg you, share my videos. Just please share with your friends. Much love from me to you. Thank you for watching.